Okay, part C here. It's asking us to find the interval of convergence, and so we have this limit. I didn't even put the limit notation in there. I will down here though. The limit then, as n approaches infinity, now let's clean this numerator up here. X minus 1 to the 2. Let's see what this is here. So 2n, that would be 2n plus 2 minus 2. So those 2's are going to cancel out. We're just going to get 2n. So we have x minus 1 to the 2n over n minus 1, or sorry, n plus 1 factorial. And then we have multiplied that by n factorial over x minus 1. Now to the 2n, but then this minus 2 right here, we could write this whole thing here as x minus 1 to the 2n times x minus 1 to the negative 2. X minus 1 to the negative 2. That's exponent there. But then that means that we can put that x minus 1 to the negative 2 in the denominator up to the numerator and make it positive. So we have that guy right there, and let's be consistent with that. Okay, so that being said, we've got now the n plus 1 factorial down here can be rewritten as n plus 1 multiplied by n times n minus 1 and so forth, but that's multiplied by n factorial, which then cancels right there. So we cancel the n factorial, so we just get an n plus 1 downstairs. We get the x minus 1 to the 2n canceling with the 1 in the denominator. So we just get x minus 1 squared. Okay, and the x minus 1 squared, then let's bring that down here, and we write equals x minus 1 squared. That's in absolute value bars. It's always going to be positive or 0. And then multiply that by the limit as n approaches infinity of 1 over n plus 1. Well, that's x minus 1 squared times 0. Well, that's 0. That's always less than 1. And if it's always less than 1, then it's always convergent, and therefore the interval of convergence, and I need some space here. I have no space. So I'm going to have to erase something. I'm going to go, let's erase this stuff right up here. Okay, so I'm going to just erase. Hopefully you have all that you need. Erasing everything here, and we were going to say, I don't have a good way to do this. And so we say, therefore, the interval of convergence is, the IOC is negative infinity to infinity. Because no matter what values we plug in for x, the series will always converge. The limit, the ratio test will always be less than 1. And there you go.